was asked to look at the formula chart, and so I will do that briefly. I do not think that this year's test will be heavily formula based, so I don't know exactly what I would need to do with this, but you could take notes on your formula chart because it is an open note test, and I'd recommend having them handy. So first of all, this formula is for the mean, and it works just like we would think it works, so don't overthink that. And this is the formula for standard deviation. Unless it's specifically about this, you could use your calculator to find the mean and the standard deviation, but that's just an idea. This is a formula, so these formulas are for linear regression, how to calculate that line. And this formula is correlation. Now remember, r squared is just r squared. So you could use that and square it if you needed to. Don't overthink that. R could be anything between -1 and 1, but r squared, of course, has to be non-negative. On probability, this symbol here, the union, is read OR, whereas this symbol here, the intersection, is and this symbol right here is the conditional, or given that. We have discrete random variables. This is countable. If you needed to make a little picture here, this would be like if I had x and p of x and 0, 1, 2, 0.5, 0.3, 0.2. That's a discrete distribution, and I've got the mean and the standard deviation for that. If I was looking at this formula, that's each number minus the mean squared times its relative probability. Binomial, remember binomial, two options. We had the acronym BINS for that, for binomial, independent, a set number of observations, and a set probability. And I see the formulas there, of course, for both the formula for the binomial distribution as well as the mean and standard deviation. Geometric, similar idea to binomial, but I go until I get the first success. And so this part here is the probability of failure and the number of failures, all but the last one. And then P is the probability of success. And I've got the mean and the standard deviations for those things as well. Sliding into sampling distributions, the standardized test statistic is the statistic minus the parameter over the standard error of the statistic. So for example, z equals x bar minus mu over the standard error. Confidence intervals look the same way. So this, for example, could be x bar plus or minus a z star times sigma over the square root of n. Now these formulas for standard error are on another slide here. And I do have another video going through lots of different confidence intervals if you want to see how those could look, but these are general forms for them. And chi-squared, it's not going to be on the 2020 exam. Sampling distributions with standard error and all of that. And so we see here, here's the means. Here's the standard deviation, or the standard error of the sampling statistic. So what I would use in a confidence interval problem versus what I would use in a hypothesis test. These, of course, are for proportions, as it says right there. One proportion, two proportions. Same idea for means. One mean, two means, or one population, two populations, and the formulas that we use for that. This stuff would be what I would use with the t distribution. This would be what I'd use with the z distribution. We don't have to do this part because we didn't get to inference on regression. So that will not be on the 2020 exam either. And that is a very quick covering of the formulas on the 2020 exam.